and sorrow, and people just aren't very happy because they don't remember how to do trigonometry. Well, I hope you remember how to do a little bit of stuff, but what I want to do is kind of briefly start at the beginning of trig. And as we go through trig, our two chapters that we did that dealt with trig were 13 and 14. The first parts of 13 were when you did your right triangles, and we did law of sines and cosine. Those, you guys had calculators. You had to have a calculator to do that, because you had right triangle stuff where you had to find the sine of 58 degrees to figure out the missing side line. You can't do that without a calculator. You had to make sure that your calculator was in degree mode for that. When you use law of sines, law of cosines, you also have to be in degree mode. Otherwise, it's not going to work. After that, a lot of this stuff was review for what you did in geometry, aside from a little bit of law of cosines or that ambiguous case. That was where the iffiness became. After that, we jumped into the unit circle. And the unit circle became pretty important. Yes, very. But if you break down the unit circle into really what it is, it's just two triangles. The unit circle builds itself out of two triangles. It builds it out of the 30, 60, 90 and 45, 45, 90. Bless you.
Thanks.
The unit circle, every piece of ordered pair, all 20 of them, or 20 entries, excuse me, on the unit circle, all came from those two triangles. And you guys learned about those two triangles last year. You learned that the opposite of 30 was some value x, opposite of 60 was x root 3, and then the opposite of 90 was 2x. We simplified it and said 1, root 3, and 2. In the 45, 45, 90, we said 1, 1, root 2. Because we gave our unit circle a radius of 1. That's why that worked. Now, when we built out of that, all we had to be able to do was generate 3 angles. 30, 45, and 60. But we dealt with them in terms of pi. 30 was a pi over 6, 45 was a pi over 4, and 60 was a pi over 3. All of their other angles that were built from them also had the same denominators, just depending upon where they got moved to. What we needed to be able to do, though, is figure out their ordered pairs. Now, one of the things that you guys didn't have the advantage of having when we were doing this before was a calculator. We know quadrantals, I hope. We know that those 4 spots are at 1, 0, 0, 1, negative 1, 0, and 0, negative 1, respectively, going positive spin. Now, if you know that much, and you need to figure out sines and cosines, who comes first?
Cosine.
Well, we know cosine comes first, but what's the you forgot? Take your calculator out.
Okay.
You have a calculator. There's a button on your calculator that says cosine. Pretty cool.
Yeah.
What I'm going to show you right now, it's not going to affect anything.
Okay, so because like, so if I've been using it all day
It's okay. Because what I'm doing here is I'm going to show you the easiest way to decipher which comes first, cosine or sine. I want you to type in the cosine of 0. What do you get?
1.
1. So that tells you that at 0, cosine is 1.
Yeah.
So that means cosine comes first.
Yeah. Your sine of 0 is 0.
And the sine of 0 is 0. It is a nice way to check yourself before you wreck yourself on the trig stuff. Nice pun, you like that? It's funny. I'm funny.
I think the cosine of 0 is like
I want to see because the special, like, you high five me.
You're literally afraid they can hear your seat.
No, I'm not good at this stuff.
No angst, please.
I always say that loud.
So the nice trick there to remind yourself of what goes first, because now building everything out, you're just using your triangles. So at 30 degrees, cosine root 3 over 2, sine 1/2. 45s, those are nice. What? No?
When you have the triangle.
Cosine of,
Oh, never mind.
You probably learned it on a Friday.
that was good. The 45, your cosine and sine have the same value. It's 1 over root 2, but we rationalize it right at root 2 over 2s. At 60, pi over 3, the opposite to 60 is the adjacent to 60 is the 1. The hypotenuse is 2, so it's 1/2, and then root 3 over 2. Everything in that entire circle is built off those two triangles, just like that. And all it stems from is knowing the two triangles, and can you find the cosine of 0 to know whether or not what comes first. That's it. Okay. That's how that works. Yes, ma'am.
And we're using the hypotenuse and not the angle adjacent, like not the line adjacent, not the line, or are we using?
What do you mean line adjacent?
So we're using, so this is the 30, 60, 90, 10 over here. So we're using this one, and the hypotenuse to find these two.
No. What's happening here is when you take and place this, if this is root 3 and 1/2, that's this point here, which means this value here is root 3 over 2. This value is 1/2. That's what that means.
And then we can assume that the triangles are on the axis when we're doing them, say, like on.
Your theta value is always placed here.
Yeah, because, like, say in the second quadrant, like, you put it like that, the root 3 will be negative, right?
It depends on what sign SIGN you're looking at. What happens now is then you have to just remember your ordered pairs, where are they positive and where are they negative. That's where you're getting it at. And it works for the x's and y's. And that's why we say cosine goes with x, sine goes with y. Literally.
So, what was that thing that did like first or fourth quadrant?
That's one offshoot of this, and I'm going to get to that, okay? I'm going to get to that. So these are the types of things that allow you to find, what was the question I had? I had it bookmarked in my,
Who wrote underwater basket weaving again? And spelled weaving wrong.
They spelled it.
Underwater basket.
I think
Underwater basket
weaving.
weaving. There's an E in there.
W.
They have an E in
Yes,
there.
the W.
That's not even, that's not an E, that's a W.
for example, unit circle allows you to figure out what's the secant of 9 pi over 4.
Oh, switch 1%.
Hypotenuse and radius.
So we have to first of all spin it and figure out what quadrant you're in to get its reference angle. Obviously, it has a denominator of, it's not, I just made this one up. It has a denominator of 4, which means we're probably going to wind up at a 45-degree angle of pi over 4. We just got to figure out what quadrant we go in.
First.
So 9 pi over 4 is 2 pi and a quarter. You okay with that?
Yeah.
So we spin it. 1 little, 2 little, and a quarter. So our first quadrant is secant positive or negative in the first quadrant? Positive, because cosine is positive. Now, secant is the opposite, or excuse me, the inverse of cosine. If cosine was adjacent over hypotenuse, secant is hypotenuse over adjacent, so this is root 2. Or root 2 over 1. You're done. That's what unit circle allows you to do. Spin it, reference angle, done. You don't need to memorize the whole thing. You just go right to it. Okay? That's why I beat you over the head with that. Lots. What's that? No, more mentally than anything. Well, Lydia, what you're asking about is this. What Lydia was asking you is this. Oh. Let me write it like this. Sine of theta equals negative root 2 over 2. This is asking you what angle has the sine value equal to negative root 2 over 2. And this is where you have to remember how sine is calculated, or when you're trying to find an angle, where do you find it for sine, where do you find it for cosine, where do you find it for tangent? When you find it for sine, you're pi over 2 to negative pi over 2. Cosine, 0 to pi. And then tangent, unincluding pi over 2, negative pi over 2. Because remember, at tangent at pi over 2 is 1 over 0. You can't divide by 0. That's why tangent had asymptotes when we graphed it. Okay.
So this, it would be like 300 degrees.
No, remember, it's between pi over 2 and negative pi over 2. 300 degrees does not occur in those two values. Plus or minus 90. That's what we're looking at.
Oh, so it's negative 60 then.
Well, root 2 over 2. Which triangle has the root 2? 45.
45.
Yeah, I was going to say.
So it's the 45s. So it's going to be a 45 degree angle down. So it's negative 45, so negative pi over 4. That's what you're looking at doing there. Okay? You got to get into that quadrant.
We have to do those like, because there's 50 questions on the test.
Mhm.
We have to do those like really quickly, and will there be like harder problems after it? So we have to save time for those? Or is like, those different tests?
No. When you did stuff like this also, we did the equation stuff. We did some of those equations. Now, I was just helping out the Yabos over there
Yeah, we got those. That's weird.
with a couple of these.
Oh, these devils.
These devils, these bad mamma jammas. Now, I look at 61. And I'm trying to solve for theta. Does everybody agree you have theta on both sides of the equation?
Yes.
So pick on the little guy. Which one are you going to move?
Oh, theta.
The minus one. So I'm going to add the cosine of theta. At the same time, I'm going to add a negative 2. So I wind up with 3. Did I say cosine? Cotangent, excuse me. Cotangent theta is 0. Therefore, cotangent theta, 0. What angle has a cotangent value equal to 0? It's going to be on a quadrantal. It has to be on a quadrantal. That's the only sets of ordered pairs that have zeros. Now remember, when you're talking about cotangent, cotangent is the inverse of what trig function? Tangent. So we have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. If tangent is y over x, cosine is, so I want x over y to equal 0, which means, can y be 0? No. Which sets of points give me not 0 for y.
Second or third.
Pi
What,
Pi
over
over
2
two, pi over
and 3
four.
pi over 2.
That's what I meant to ask. You're right. It's going to be at pi over 2 and 3 pi over 2, 90 and 270. So my answer is pi over 2, 3 pi over 2.
How come he answered, he said it was pi over 2 plus pi n?
It was asking, that's my next part, if it asks for general solution. On the test, I will make sure that it specifies within one ringy-dingy or within general solution. This would be the pi over 2, 3 pi over 2 would be my answer if it was in one revolution between 0 to 2 pi. If it asks general solution, the reason that it says just pi over 2 plus pi n, because to get from here to here is pi. It's pi to get back, it's pi to get back, pi to get back, and so on and so on. Okay.
Which one is the one that has the pi over 2 n?
That's if you're at 45 degrees in all 4 quadrants.
Okay.
If you're at pi over 4, that happens when you have a plus minus tangent problem.
Bottom's back.
Don't talk about them anymore. I just sort of hold that on my desk. Thanks. Okay.
Do we need the graphing ones from the, yeah.
I'll get to that.
Yes, I know.
I'm gonna do one more of these real fast
Actually,
though.
probably did really well. He didn't fix it, he brought it back. Yes.
Once again, pick on the little guy. I know it's mean. We're gonna bully the little guy
Good
here.
boy play.
So it's
I'm not, I'm pretty sure I'm as tall as you know.
Nope.
Oh, wait, no, negative 7.
So I'm gonna add the 7, but I'm gonna subtract the 2 root, or excuse me, I'm gonna add the 2 root 3, I'm gonna add 2. I'm gonna wind up with 2 root 3 equals 4 secant theta. We okay with that?
Yep.
Divide by 4. So what angle has a secant value of root 3 over 2? Which triangle has the root 3's and 2's?
That's a 30, 60, 90.
Secant is the inverse of what? Cosine. So cosine. Did it really give me that? It's supposed to be something. It should
It
be.
doesn't work.
It doesn't work.
Because if you flip it upside down, there's nothing, the adjacent to cosine isn't 2.
Right. Huh. I think there's a typo on that because this one should have. It should have worked out the same thing with this one where it was 2 root 3 over 3. Yeah. It should have been the 2 root 3.
It should have been cosine and not secant, right? Because that would be cosine.
What's the for an answer?
Let's
Yeah,
see what the answer
I bet you it's supposed to be a cosine. You're probably right. I just
The
recognize
answer
that.
is no solution.
Ah, that's why I did that.
Come on.
Can you have a secant value where you have? Will you get that value? No,
Okay.
this is a no solution.
Shows
Can
no
we
one
just make
problem.
it a cosine?
If we had if this was a cosine, then we could do the problem. Yes. All right.
63, that one has a solution, and it's the same style problem.
Like the root 3 over 2 again. Yeah.
What's 2 divided by 4?
It is 1/2. Yeah.
The other thing that's come up a couple of times today also.
One.
Oh, bad, I don't know. Oh, these were
Oh, those
nasty.
suck. Bad.
Oh, see,
You have to remember.
Oh, that little half.
I know the second square.
Yeah, you can put these on.
This next one's gonna be
Yes,
plus
yes,
cosine, which is
yes.
cosine's clear.
CSC.
Are you okay?
Yes.
Okay. Bad memories. Bad mamma jammas. On the chapter 13 test junk that I gave you the other day, this one with all the old test pieces on there. There is a good one of these.
You should not take.
It's the chapter 14, test C, number 8. It is cosine over 1 minus sine minus tangent. And I want to simplify that. Okay.
Should you take the square root away and use that? Like,
No, that won't work. So here, what I'm going to do right off the bat is notice that I have a cosine and a sine and a tangent. I'm going to rewrite tangent in terms of sine and cosine. What's tangent then?
cosine of sine. Or you sine of cosine.
Oh, it's,
What's wrong?
C8.
It's page 107.
Yeah.
I'm just doing this. In order to subtract fractions, what do you have to have? So the common denominator here is going to wind up being 1 minus sine times cosine. Fraction on the left needs a cosine. Fraction on the right needs a, well, sine times the 1 minus sine. So now, in the numerator, what I'm going to do is distribute to that secondary term here. It's negative sine times the 1 minus sine. When I do that, I get my numerator of cosine squared minus sine plus sine squared. What can I do?
Make a 1 cross out the cosine.
Oh, so you want to kill the shirt.
I can, we can get rid of the
How
cosine.
many puppies do you want to kill?
Can't do it because there's subtraction.
You can do nothing.
If you reflexively move numbers around, you can make
Yes,
a
ma'am.
1, right?
Make it 1 minus sine.
Very good.
Yeah,
What's cosine squared plus sine squared?
like I said. Perfect.
1. Yeah, it is.
Chunks.
Killing puppies only applies to back
No, it's foiling.
Now what do I do?
It's 1 over cosine, which is,
Now I can do that because this is its own term, because I can put 1 here.
You did it.
And what's 1 over cosine? You seek and destroy that one. Seek and destroy.
What chapter is this?
14. The frowny face. God bless you.
Oh, wait, time out. He just changed the slide the moment that he sneezed, so it looks like he sneezed to change the slide. That was really weird.
No, just,
Yeah,
no.
oh, yeah.
No, he did
Wait,
not.
please stop.
Yeah.
And how much you should trash it? I'm gonna stop sorry.
Keep it so neat.
This one.
Do you have a paper, Fred?
Yeah, they can
No.
do
I heard it.
Is that you can
No, I'm just gonna do a couple extras here and there from these because I know how much we love them.
Aren't we supposed to put them on?
I'm not gonna.
It's just mad.
I would do that. So guys, in the case like this, I have cotangent, secant, sine. I would go ahead and rewrite everything that I could in terms of sines and cosines. Cotangent is what over what? Cosine. So it's cosine over sine. Secant is what over what?
1 over cosine.
Oh, I see what you're doing.
Oh, it's 1?
Oh, it's 1.
Would you look at that? It is.
Sounds nice.
I'm assuming this
Awesome. That's like what happened.
That was kind of rude.
Yeah, they're probably. Super sweet. Like, stop it.
Yes. Don't humor me. Don't, just avoid that side of the room.
I understand what's
It's like you're boxing a little
Yeah,
bit.
you
You're gonna be said.
You know it. All right, take a look here. Look at your numerator. Numerator has its tangent plus cotangent. Notice that they're inverses of one another. Once again, it's forcing you to get a common denominator and turn this into a complex fraction. So what I want to do is just work with my numerator off the top, and I get, that wasn't meant to be punny there. And do that. Let's give me the common denominator. So my common denominator gets me cosine, sine. The numerator becomes sine squared plus cosine squared, which is what? 1. So I have my new numerator as 1 over cosine sine. At this point, I'm dividing it by secant squared. Yes, ma'am?
Back there, when it's like cosine over sine over with plus cosine. Oh, we can't. It's not multiplying anymore.
Good conversation.
Yeah.
Or better yet, see if I do it this way. I'm going to do this. This is the same as times 1 over secant squared. Everybody okay with that? Instead of dividing, I can say it like this.
Yeah.
What is 1 over secant squared? Cosine squared. So you wind up with this. Cosine squared over cosine sine. Stuff cancels out, which gives you cosine over sine, which is cotangent. Now think about the complexity of that. Not finalized. I don't have to give that test until Tuesday. I got time.
Such a pleasure.
No, I'm a perfectionist. Difference.
But chemistry is held for us.
Okay. Let's see. After trig identity, so we did the graphing. Because I know how much you guys love the trig identity. When we graph stuff,
Crap, I don't remember that. That could be a
you had the two generic forms of graphing sines and cosines. Oh, yeah.
I remember this.
We did what? Now, you have a graphing calculator.
Yeah, we do.
Do you know how to use it?
Debatable.
Debatable. Okay. There's a button on your calculator that says y equals. Did you know it was there?
Yeah.
Sweet. Then you're halfway home. For example, let's look at, where's the graph? Look at 56. 56 is not written in a happy format, is it?
No, it's written in
Because
unhappy.
where is B hiding?
Inside of
That whole parentheses.
It's inside the parentheses. Okay? The B value is hiding within the parentheses, which is not nice. Which means we want to get that B value out of there. How do I get that B value out of the parentheses?
Divided by 3.
Divide by 3, or I can multiply both parts inside there? Oh, I didn't know if you had it. So I was just trying to be nice.
Thank you.
You're right, it is that C, because that's exactly what Lily would say. Because I was trying to be nice and give her something. And I have
Sorry, no, but
See?
I didn't realize it was that.
No, Lily goes like whoever wants that.
Here.
It's the seat.
Make your
Does that
hair
give
color.
points?
Oh, sorry.
It's okay. Do I get points?
No. Take the 3 out. You get 3 cosine of 3. I'm going to use x because that's what we generally use in class, right?
Yeah.
Now, when I take a 3 out, remember I multiplied it by a third, my h value here becomes minus 2 pi over 9.
It's a funky number.
It is a funky number. We always wound up with somewhat decent breakpoints, nothing that was that nasty.
It's nice.
So we now know that we can find our amplitude and our period and our vertical horizontal shift. I know that my amplitude, my A value is what?
3.
My B value is 3, which means my period is 2 pi over 3.
Okay, so we use like vertical cosine.
No, it's the second one. It's A, B. It's A cosine B. Okay? So that gives me my period. My vertical and horizontal shift means I'm shifting it left or right 2 pi over 9. Correct. I'm shifting to the right 2 pi over 9, and am I going up or down 2? Down 2. So at that point, it's just a matter of if you had to identify parts, can you put that in your calculator?
Yeah.
All right, type it in. You want to type it in this format, like this. Actually, you know what? I believe when your calculator opens up, I think as soon as you hit cosine, doesn't the parentheses
Yeah.
open?
Yeah.
Then you can do it this way. You have to put it in that way. But in order to identify your period, you got to pull that 3 out.
Can we use X or do you guys?
Yes, you can use, no, you can use X. So in our calculator, if I type in, let's see, what was it? Y equals, it was 3 cosine. Then I'll put 3x minus alpha y equals fraction 2 pi over 3. Close my parenthesis, subtract 2. And I graph it.
This doesn't put L
What's the fraction
Wait.
of 3?
Mine is a straight line.
Yeah,
Why
so
don't
it's
you
mine.
say
Mine
over
says,
3?
what's mine?
Oh, it's one of those huge curves.
No, because when you put it in, because once you do it on the cosine button, it automatically opens the parentheses. So I have to make sure I have it inside.
Straight line.
Mr. Murphy, mine says, mine says invalid. It's the same as, oh my goodness.
Mine's also a straight line. Did you reset it?
Press the button in your calculator. It says mode. Switch it to radians.
Is that why it's saying invalid?
No, yours is probably because
You, because you have.
Oh, you got it.
Yeah, you scatter plots and stuff. Oh, you cleared your scatter plots, but you didn't turn off the graph for scatter plots, so it was just blank. It was, you couldn't portray an empty scatter plot. And we fixed it, we fixed it.
Good job, bud.
Not you.
Um,
Now,
Go to-
obviously, your calculator can graph trig functions. You just didn't know that. Because I didn't tell you that.
Last.
Well, that was nice.
That's not right.
Yeah, I know. I
Last.
forgot, is this
Just
what
like that.
story is?
What's
I
that?
forgot which story is a part of this.
That was the modeling stuff. And that, you had that, the graph. You'll get the equation on that one. So when you're looking at your period value here, obviously your table of functions are going to give you a whole boatload of crummy decimals. But you could at least look at, oops, that's not the table set up correctly.
Mr. Murphy, what mode did you say to put it in?
Radians.
Radians.
It'll give you a whole lot of crappy decimals, but those decimals are all equivalencies of the pi value. But it just won't show you what pi values are. But at least you get the idea of the curve. Yeah.
So, for
Correct, but it always started at the A value, whether it's positive or negative. In this case, our A value is positive, should have started at 3 and worked its way down. So and this one had the, did I type it in wrong? Why is it at 3.5?
I did not, I got 0.293.
Okay. But it gives you the idea of what we're going through, okay? Tangent functions, when you find period for tangent, remember your tangent values is pi over b. And your absolute value b. I don't think we ever had a negative b, so it's not a problem. Okay? Then you had asymptotes at half those. Remember when you had asymptotes and tangents? That's your, then your your breakpoints were half of the period. The period is labeled out by the asymptotes. The breakpoint is halfway in between, wherever your 0 is, get plus or minus. So if you had, let's say it was 2 tangent 4x, 4, let's say x minus pi. I won't even do a shift, we'll just do 4x. Let's say it was that. Our b value here is 4, so my period would be at pi over 4. Tangent will always go through the origin, start. My period is pi over 4. That means my asymptotes are going to be placed at half of whatever this is, plus or minus. So be at pi over 8 and negative pi over 8. Because the distance between here and here is pi over 4. Okay, that's how that works. And then my breakpoints would then be half of that to be pi over 16 and then pi over 16. Your A value tells you where it's going to go to. Bless you.
Bless you.
Bless you.
Bless you. Anybody else?
Bless you.
Colin, you didn't say anything.
It was Miss Luder, she'd yell at us right now.
Is tangent increasing from left to right or decreasing from left to right when it's positive A? Increasing. So that means I have a negative here. It's negative.
Wait, I forgot. If the A value, if the A value is negative, is the curve going the other way?
In jail.
Okay. What else is there a trick?
There's actually a lot.
You guys still have all the, I mean, you guys basically did every single one of them I could ever come up with. You really did.
We can be done now.
So for each of these graphs, each function is ratings, you just pop out of the calculator.
You want to make sure you know how to identify your periods and latitudes and where your shifts are going to wind up. Make sure you know how to do that. Obviously, the calculator will help you do that, but it's not going to give you the clean numbers that I'm actually looking for.
Considering that the last one you gave us all decimals, like.
It doesn't, they're not real decimals, so those are decimal equivalencies of pi. You still have to know, if I ask for a maximum or minimum, you have to be able to identify what is that value. Yeah. Says we did it before. Yeah, what do we got? Graphing, yes. All the graphing stuff, basically, for all the shifted things, is 14.2. 14.2 was all the graphing with all the shifts. The trig identities, I think, was 14.3. Yeah.
That's interesting.
Yeah, 14.3 is the trig identities.
I would have I would still do it. I'd be.
And we only did Pythagorean identities is really all. We didn't do any of the cofunctions or the negative angles. We didn't do any of those.
One's for
I kind of feel like this final is gonna be.
I love it.